Well, normally speaking, I speak very loud, so I don't know whether there are loudspeakers or not. I come from Zaragoza. Zaragoza! And just a joke, okay. So this is the first speech after lunch. So I was thinking, it was like, well, otherwise I will say that this is about coronavirus and that's it. Well, basically, welcome to industrial protocols and local roads. I was a little bit dyslexic when I did the slide. Well, I'm David Meléndez, and this is my Twitter address, so that you can follow me and you can increase my ego. Well, I'm an engineer in embedded systems and software R&D. We do hardware, and well, these are my stickers, just to show off, and so on and so forth, because we all know that, well, who has gone to DEF CON is more beautiful. I couldn't be more beautiful, so, well, I couldn't, but that's the point. Well, I'm the author of Hacking on Drones, and I'm the author of other machines, some machines. The ones that know me, you know me as the guy of the drones with routers. So let's get to the nitty-gritty. So the speech started in a very informal way. My parents called me through WhatsApp, and they told me, hey, my air conditioning is not working. It's like, wow. Fortunately, it was not TV. And I said, okay, so let's see what's going on. I went to Zaragoza to see my parents. And it was a bad time at Zaragoza because, yeah, we have winds, etc., but you are at a hell wind tunnel, basically. So it was like, well, we need to solve this because, well, poor parents. Hello, Dad and Mommy. And I decided to, well, I said, well, let's solve the issue. Let's make AC work, at least. Improvisation. So the first thing I identified was the remote control. This is maybe from year 2000. I was young by then. And they said, no, when you push it, when you press it, sometimes it works, sometimes it doesn't, and it is increasingly not working. It's like, well, that's a scientific description with a very high level of accuracy. And I could see it. It was like, well, I'm pressing it, it doesn't work, some weird things happen, there are some blinking lights, these LED screens, and it started to get crazy. So that's a remote control, okay? So I said, well, it seems that remote control is doing weird things. I said, I'll have a look at it in Amazon. So it's like, okay, I'm going to buy it right now. This is a great offer of a thingy that has that yellow plastic. It's a little bit rancid, so to speak. It's old-fashioned. It was like, oh my God, I want it to be smart. It was like, okay, let's calm down and let's put this option aside for another time. So I kept on having a look at things, identifying the AC, because when it was installed, I was a pre-teenager, and it was like, well, what have they installed here? And the first thing I did was to go to the bathroom, where I have the embedded cassette. It is over a technical ceiling, these ones that are embedded. And the first thing I did was to identify this cooling unit and download the manual, the thing that we had never done before. I said, well, it seems that there's electronics here. It was like, well, I'm going to take a picture. I want to go back to Madrid. I'll investigate about it. And the controlling board was at a specific part, a specific place. I took a picture, skipping the barcode. Just maybe you could hack it, but it was like, okay, no worries. So I've hidden it just to show off a little bit. And here we can see the controlling board, or the electronic board. And it's a board that it looks like an expensive Arduino. But the point is, it's very expensive. So this shit is expensive. So it was like, well, if this breaks down, so that's it. So this is a picture, maybe it tells you nothing. And this is the picture that is what I can see from the device to the remote control. And it was like, well, I can see an out here, 12 volts, something that says RS485 and a CLK. So having a look at many brochures that didn't have that have nothing to do with that model, it was just generic research. So on one of these lines of the PDF, I found CLK, clock entry for working and stop remotely. It's like, what is it? Clock? Clock of what? So in the end, having a look at the structure, the connections are, well, one of these connections go to the remote control, other ones go to a more shabby remote control, and other ones, well, you can see the structure there. Okay, so it was like, I'll try to put all cables together. So it was like, well, maybe I could break more things here than the ones that are already broken. But it was like, okay, so it seems that the explanation matches. CLK is not a communications bus, as we can see on the structure. It's just a contact closure. So if you put the cables together, so the air conditioning switch is on. I think it was it has some default conditions at 21 degrees Celsius, I think, and that was the established point to cool down the house. So the temperature control is local, and it is ignoring the remote control. So it was like, okay, so I can change the cables of the communications bus to the CLK, and I'll put a switch. It's like turning on and off, or off and on. As we are in Zaragoza, there's a switch here. So when you're hot, you push it, and you're cold, you switch it off. You will be the thermostat. It's like, well, doing some human machine learning. It was like, this is how it works. But you don't have to be as the pigeons that we've seen on the previous slide in the shade. So all the other options about, well, this fan or the other fan, everything is set up by default, and you can buy a remote control on AliExpress. It measures the environment temperature, and if it's hot, it closes the circuit. If it's cold, it opens the circuit. So that was a speech. That's it, and thank you very much. Now I'll speak about talent later on. Yeah. So I said, okay, so then what a piece of bullshit. It was like, well, I know that I'm a really sexy guy and I have a great talent, as Roman said, but it was like, well, let's do some more things to fill up the paper. So I took the remote control and I said, well, let's see what this is. It's WBMS Mini Supervision Station. What? Amazing. This was amazing in year 2000. Some buttons around that were really suggesting with back lighting, and it was like, it almost has a sigh. It has two cadmium batteries, I think, that are rechargeable, by the way, and it even had its own sigh. So and it said something about Modbus interface. So I said, well, let's see if I can use this for anything. And it's funny because this unit allows, according to the manual, allows us to control many AC. So as far as I know, my parents only have one. Because then we have a regular remote control to manage this device. But I didn't have that. I have the other one. I had the other one. So this is local control of the unit, and this would be the infrastructure one, some kind of infrastructure. And if you have a look at the manual, the RC is to plug in some AC devices, but up to 10 and just one zone. And after that, we have the red area. There's the supervision central that says the manual. Well, there are 12 volts for feeding, and it goes to the bus. A minus B plus. And for the ones of you who are familiar with this type of hardware, it's an RS485 bus. And if I plug in an RS485 adapter to the PC, maybe I can see something of what's going on. Okay, so it was funny because it's either the supervision central or it is on RS485. So what do? Both of them are going to the same connection. So this started to piss me off a little bit. I bought a device on AliExpress that was a USB RS485. So I'll plug this and plug and play, and plug and throw it to the trash because I couldn't see a thing. So I tried different programs. I tried to see it on the console, and I couldn't see anything. There was no communication with anything, and you can't start playing with something that is already working. But there was air conditioning. The AC worked. It was like, okay, so I won't try additional things. So I took the remote control to Madrid. I started to read the manual, and it said micro BMS. Okay, manual. Okay, this is connected as we've seen before. You have the two batteries here, two batteries in case lights go off, critical infrastructures. You can control several units through a shared bus. So everything works up to here. There are switches at every unit, so you tell him about what address do you want every device to have. So you can set the address with micro switches at every cassette. In this case, it was address 0. So it was like, here we have it. And I said, okay, so let's see what's that of BMS. Well, BMS comes from Building Management System, and it seems that it is a system to manage smart buildings. So this deployment has to do with this. So I started to look at Modbus, TCP/IP, BACnet Modbus, NBP Modbus, and whatever Modbus. So any of these had nothing to do with this system. So I googled UBMS and the brand. So I found 153 results that were selling the remote control. It was like, okay, so screw it up. So I said, come on, let's draw it. Let's see how it works. So I opened it. I took out the batteries, and there were things that I could identify. Well, the feeding system, where you can see RS485, that is not an Air RS485, and that was a little bit misleading. An apron and a little bit of Loctite. This is, instead of swelling, you use glue so that it is a cheaper. There should be a chip there, and this is the type of the type of connection when you want to save that welding. You put some glue on, and that's it. This usually happened in Chinese toys, but this was a 200 euro Chinese toy. Okay, so I had a look at the apron, and it was like, well, it's an apron that, well, identified the chip, and here comes the nitty-gritty of everything. Here you can see me. So wow, this is amazing. So I had an oscilloscope that I bought on AliExpress that said oscilloscope 15 euros. So the demos that I do are conceived for real salaries of experts in cybersecurity in Spain. Do you imagine that what journalists say was true? That would be crazy. Just a minute. I'm gonna laugh. Here you can see the remote control. I have it. I mean, I'm not kidding, okay? So I have connected this, wait, to an Arduino. I'll show it later. Well, the point is that I connected it to this oscilloscope, and I found a square signal. So there was a square signal. I'm going to push the button now to lower temperature. Well, that's 15 euros, okay, so what you want? So it was a square signal, and it was like, it doesn't look as a serial port. And it really didn't look like anything I knew. So I went to the workshop, to the company. So let's see if it works. So full screen, hacker, yeah. Well, I did some snapshot at an oscilloscope that allowed me to do some snapshots, to take some snapshots, and I could see, well, here I knew that the bit rate, well, the baud rate was 1,200 bauds. So here you can see a snapshot. And this is the same, but on a screen, on a better screen, so to speak. So here you can see a signal that when you press any button, there would be a preamble, a big preamble. It goes up, it stays stable, it goes down, and after that it starts to convey information, to transmit data, basically. So this is the whole frame. So do you see anything that would let you draw any conclusion? Because we can see the preamble that I've told you at the beginning. And after that, don't you see it again? Yes, well, the point is that if you move the screen, you could see it 3 times. So if you have a look at it, you see that the same signal repeats 3 times. So you push the button 3 times. This is what I've shown. This is what I've shown you before. Instead of buying the RS485, I'll buy it at 3.3 in order to put it in an Arduino that could adapt the tensions so that I can read that square signal on an Arduino, because I won't be logged into an oscilloscope to see what we have there. So as the baud rate is very low, 1200, what I can do is to link it to an Arduino, to link it to the interruption pin of the Arduino, so that it reads when the signal goes up or down. Here you can see a sniffer that's clearer. There's no insulating tape here, so I rock. So here you can see that this comes out from the no RS485 to the levels adapter that goes to the Arduino, and the Arduino through a serial port goes to a PC. So what did I do with the Arduino? Well, basically what I'm telling you, when it detects a rise, for example, it would detect an interruption. It would say there has been an interruption, and when it goes down, exactly the same. It has gone down to this timestamp. So this would be sent through the serial port, and I painted with an improvised canvas with HTML5. So let's see. So So as far as it is plugged in to the PC, I press on it, and it says, well, at this time it has gone up and down, up and down, up and down. So I take all this, and I didn't use a web server. I didn't use anything. So it's like I go now to, well, maybe you could say, maybe you could have used a processing. It was like, no way. Okay. Have the input, I press enter, and on a canvas I can see the square signal that we've seen at the oscilloscope. And now I need to know what the hell is that. So every time I press it, every time I press the button, the signal changes. Let's see. So what I did was, well, temperature 30 degrees. Okay. 22, 21, that one. Okay, so the only thing we have to do here is to draw conclusions to see how to decode each part of the message that is sent. So what conclusion did I draw? I don't know if you're familiar with the Manchester coding. It is this type of this boring stuff that are taught at the university, and you never need them, and the companies don't want you to learn this because it's necessary. No, but just relax. So as I was saying, the Manchester coding, so holotypical coding in transmissions, data transmissions, that, well, the signal, the clock is included in the signal. It's in the signal. So instead of representing a 1 as a upper point and a 0 as a lower point, I wait, and depending on where it is, if I go up, it's a 1. I'll wait, and if after that I go down on the next round, so to speak, it would be a 0. But I always need to be before the piece of data at the position up or down in order to go up or to go down. I don't know if I'm messing this up a little bit, but I would be here before, well, if I go down, it's a 0, and if I go up, it's a 1. So before transmitting the piece of information, I have to be at the opposite position of the data that I want to convey. So this is the Manchester coding that is everywhere around the place. And taking that into account, you would say, wow, it's very easy to transmit a 1 up and a 0 down, but how many ones can we have there? If there's no rate that divides me in slots, how many ones I have, maybe I have either 1, 3, or 20. So that's the reason. So after playing that, as it was a PlayStation, you have the different commands there. The on-off button is the first bit. We have the swing mode, the cover. I didn't want to put it in hexadecimal or anything like that before, because, well, this is all binary code. The green thing is a temperature, and part of 20. Well, we have 4 bits encoding temperature, the temperature of remote control. So there are some zeros that always tend to zeros. So we're working on it, right? So the project that I'm working at right now, it's like, well, now I'm going to manufacture my own thermostat that will be according to this, but for Linux, because Arduino was very good, but it was like, oh, it would be cool with a Core board or with a Linux board or with a router. It would be good to, well, without having any microcontroller, with one of the pins of the router, it would be good to send commands. And guess what? A driver that can swing one of the GPIOs during that time frame. Okay, so we are working on it. And I'm studying from my previous project, that is my thermostat that I have at home here in Madrid. It's like, did you do it with the cheese case? It's like, no, I spent €1 at the store. So it's a router, and as there was one additional line on the screen, you do scrapping of the EMT to the lines that I use, and I saw the minutes that the minutes left for the metro to come. It was like, there's one additional line. What can I put there? David is very handsome. No. So, well, that's the manual, and the manual annulation would be the switch at the top. And this was the thermostat demo. This is what I wanted to speak about. And, well, you know that we always tend to speak about the things that we are expert at. I didn't know whether to speak about the drone again, and after that to speak about the thermostat, or the other way around. So I did. So this would be the surprise, that I had the description of the speech, and supposedly here says drone. But when moving the LibreOffice to PDF, when converting it, it seems that it didn't work. So some pieces of news, just for you to know. I always troll the anti-drone industry because it's the Schrödinger drone. Is there any drone? Isn't there a drone? What's the mystery behind this? It was like, well, you see guys with bags, with guns, and after that they need to do that noise with the mouth, choom, choom, choom. it was like, well, pow. Well, I think it's not very ergonomic. The fact of hiring a guy to be night and day around. Hey Paco, please go out to see whether you see any drone or not. There are many anti-drone systems. This is like AliExpress, from 10 to 1 million bucks. So, this speech about Interceptor project, well, this is a project that I presented 2 years ago here at Rooted. And it was about a drone, a very small drone. There are people that know me about they know me as the guy of the drones, and as my previous drone was very big and it was really cumbersome to take it to the airports because they didn't look at me very well. So I tried to manufacture a smaller drone. So I said, I'll make one that looks to be a toy, seems to be a toy, with Chinese sticks, so that it's very clear that I've done it. And it should have hacking capabilities, but with the minimum hardware possible. Maybe, well, this is important. Okay, if you want to do this project, you need to take this into account. Okay. Hey Roman, don't laugh that much, guy. So, I already presented this project, and I decided, well, I had a protocol. I control it through the Wi-Fi, but I created a protocol so that they could control me at speeches that used beacons frames. So the remote control data transport went through beacons frames, sorry. So the PC and the drone went into monitor mode, and they inject packets, coded packets, with their library, encoded library that, well, I haven't done this. Don't do this at home, kids, okay? So use an encoding library. So up to there, everything was fine, but I was still using the Wi-Fi bandwidth. So although they couldn't troll me with de-authenticators or attacking the Wi-Fi or the protocol or whatever, because they couldn't disauthenticate what had not been authenticated. So we could do jamming to the Wi-Fi system in bulk, so to speak. But I say, well, these rifles are by default at the Wi-Fi's frequency, so it doesn't matter how cool your protocol is, and because they can jam you, although they can't disauthenticate you. So these protocols, these anti-drone systems are based on the fact that they are designed, they expect that drones work at very specific frequencies. In fact, they tell you, what do you have, the kit home, the professional, or the premium one, in terms of frequency. So I had a look at different options. So without a new drone, what could I add to this one? It was like, well, we have a classic RF. Maybe I could put a LoRa. 3G or 4G has already been done. And what about FM? So FM works in a quite funny way, because you have the audio channel, the mono channel. Here you can see it here. And after that you have the two stereo channels. And after that, mate, you have something that is called RBDS or RDS. Here you can find the emitter information. Whatever, BBC network, BBC News, and you can see it on in the car. You can see the station name. I said, well, these are digital data. with information. It was like, yeah, you can see it here. You can see it clearer here. And what was interesting this time was the RDS data, where these data would be. So there was a project for Raspberry. I'm not a very good friend of Raspberry. I said, okay, I want to find an hack RF. So let's stick to the budget, okay? Let's follow the budget. It was like, well, I have a project where PIFM makes a Raspberry oscillate, and it creates an emitter with a pin code of Raspberry. And you can send audio with this thing. But you can also convey the name of your pirate station. It's like, David, that's illegal. You're a bad guy. Yes, but if you put a very shabby thread, it wouldn't be possible to do it. This can't, well, in real terms, this can't be done. It should have a range like the ones that these devices have, the ones that you put it in your car to listen to your own music, having that station synchronized in your car. Okay? So what was the idea? It was like, well, the concept is to pick the USB remote control. This is not a drone emitter, okay? It's just a plain USB remote control that is connected to the PC, and the PC is connected to the Raspberry. That conveys the commands that I'm sending. So the Raspberry sends through that channel, through that alternate channel, the lever data. And apart from that, well, I'm sending Wi-Fi beacons. I'm sending it through both sides. In the drone, I've put a mini receiver. Sorry. So this is €0.50. It was like, well, it costs €3, but I mean, in terms of size, this is a mini chip that is at a very small board, and this is connected through a boost C2C to the drone controller. And as far as the controller has been manufactured by me, I have total control of the drone. So I can connect whatever I want and whatever it is able to manage. So in this case, it would be tuning an FM frequency, and it gives me the RDS information at different memory registries, okay? So you say, after coming to this point, what was the idea? Send the data through two channels. One channel would be the side channel, because in fact the primary channel is the side channel indeed. It's not a regular Wi-Fi, but besides, you have a fail-safe that goes through FM. So this would be a concept attempt, so to speak. And what I would do, let's see whether it is connected or not. I didn't have a budget for another USB flash disk. I'm sorry. No, just kidding. But feed doesn't work here. It's falling down. So something's wrong here. So what does the drone do? With the chip that is wearing, he sweeps the total range and he looks for a bandwidth where there's no FM frequency working. So it takes the lowest signal intensity and it says, well, the best place for you to transmit everything is at this frequency, and this is the frequency that you can see here that says RDS, okay? Now it is 154.3 MHz. So if you take an SDR, you would see that there's a station that is basically transmitting silence. So it is transmitting silence in audio file, but the RDS, it is transmitting bullshit, apparently bullshit, but it is transmitting the levers, okay? So basically for you to see it, well, the drone's flying unless something is broken down. So the USB flash disk is not working, it seems. So I'm going to show how the RDS is before running out of time, because, well, you can watch the video of the previous speech if you want to see a drone flying. Okay, so this is the drone dashboard. Okay, I'm going to put a little bit bigger. I think that I'm messing it up even more. Okay, so I'll stop the flight control so that you can see the thing. So I'll stop the flight control. Stop. So now we wouldn't see anything here. Okay, so this is stopped. So there's another utility that I took from a Raspberry Pi that tunes the chip, because Linux drivers are terrible in the branch of PRVT. So here I can see what are the current registries, where it has been tuned, and after that, well, you can see there, if I move, if I make a move, well, this would show the station information, but in this case what I do is to send the remote control information. If I move the levers, well, it has stopped anyway, but this is how it works. So this is where we would see the remote control information at the RDS device. Okay? So, if you have any questions about this topic, well, I will have a look at something, but if you want to ask me in the meantime, we have like 10 or 11 minutes left. So I want to see your hands, please. There's a light here that is burning my eyes. So I have one question for you. So these anti-drone devices, well, many of them do not work flaming. Other ones have exploits that take the drone's control in order to land it, and so on and so forth. The advantage of your approach is that you've done it on your own. So unless you're bugging you at home, and anybody would have access to your platform, but I'm sure they're doing it. So what do you think about this approach? Well, there's an increasing number of people telling me that the anti-drone systems that they have, well, they want to include that additional step in not having to move to the next step, that it is either a physical action, shot, so to speak, or fry it. So I don't know how real, I don't know if this is really interesting or not. I mean, the fact of having people that are able to develop all this. There's a specific company with whom I've worked at an airport that have researchers having zero dates of all the devices that can be applied to land them, so that you can use a mesh or something like that. So we'll have to think about this like an additional step, I would say. Any questions in the audience? Please wave your hand. My boss wants to ask me something.
Thank you very much for your presentation. So this is a suggestion as well as a paranoia. Tell me how you feel about it. I researched on backfreaking, that is to say, a screenshot through kind of tempest. And one of the proof of concepts is using an AM radio, where you create music with a monitor of CRT. Will we see you flying a drone in our next RootedCon with CRT? Well, that's a good idea. Indeed, this is the same concept actually. You can use CRT as an emitter. One of the buses, you use it as an antenna. Yeah, horizontal or vertical refreshing is used as a hertz generator. Well, Raspberry is cheaper, but it is not a school. Yeah, you're right, but well, if you go and do proof of concept, you take your monitor with you, and well, I like your approach. I find it interesting. This is a VGA HDMI adapter. In a has communication computer, they lifted a false base station with a BTS just by playing with the emission from this device. They had a hack RF, and this other thing, 10 euros. Well, one of the attempts that I made was using this thing. I attempted using it, but it is out there, because it also uses CPU from your PC. So that's the problem, okay? All right, any other questions or last question? Oh yes, there is a question. And what about using visual references? I think we discussed this, the two of us. Imagine that I want my drone to be fully autonomous so that it is not flamed, it is not interfered, and I want it to keep this this device, okay, to fire it at you. Okay, that's another nightmare for anti-drone systems. If you don't transmit anything, there is nothing to intercept. My top worry is that you mentioned. Researchers are asking themselves, what can we do here? And then we move on to the next thing. What happens with a drone that doesn't look like a drone? And what happens with a pigeon drone? Well, Chinese have already done that. Is it a pigeon, robot pigeon? Do we shoot anything that moves? So if a drone that looks like a drone, we don't know whether it's being a drone at the airport or not. Imagine that if you see pigeons, messenger pigeons, flying all over the place. So that's the point. So do you think that this is an actual driver to stimulus to your creativity? Is it because of the low salaries that you are getting? Do you think that paying high salaries would disincentivize all such a huge creativity? He's my boss, by the way. Yeah, I brought my boss over here. Because I knew you were to say that. I have a good answer. I come from embedded software. I don't do cybersecurity. I don't work in cybersecurity. All right, so thank you very much, David.